Okay, measures of central tendency. So this stuff, everything we're doing today, you've pretty much seen before. Measures of central tendency is just a numerical way to find the center of your data, to find the middle. So the first one is mean. You guys have all heard of a mean, right? The only difference is you probably haven't talked about a population mean versus a sample mean before. How do you find the mean or the average of something? Add them all up and divide by the total number, right? So your mean, it can be called the arithmetic mean, that's just your average. So we add all the points. Divide by the total number. We have samples and we have populations. We know the population is the entire group. If I am able to find the population of the entire group, like if I wanted the average test score in this class, could I find that? Could I take the entire population, the entire class, and find your average? Yes, that would be a population. The variable that's used for that, it's a Greek letter. It looks like a U with a really long tail in front of it. It's called a mu. Okay, so just a Greek letter. Statistics have a lot of those. So if I'm talking about the population, I might just say find mu. And I expect you know that's just an average. If I'm talking about the sample, let's say I wanted the average age of all registered voters in the United States. Okay, maybe I don't have a bunch of time. Would it be time consuming to take every single registered voter in the United States? Yes, so I might take a sample and look at that instead. When I'm talking about the sample, we use X bar. So X bar and mu, they're both telling you to do the same thing, find the average. I just pick a different letter depending on which one I'm looking at, a sample or the entire population. All right. So let's do an example. So these data represent travel times in minutes to work for all 7 employees of a startup web development company. If it's all 7 employees, is that population or sample? Population. Okay, so here are your 7 points. If I were you, you don't have to write down everything. Just put example 1 and jot down those 7 numbers. All right. I want the population mean for that. So how do I find it? Add them up. What variable would I use? X bar or mu? Mu, because it's the population. So I'm going to do 23 plus 36. And what do I divide by? 7, because there were 7 of them. Okay, and when you add all those up, what do you get? And 174 divided by 7? Okay, 24.857 approximately. I didn't tell you how many decimal places to round. Please do not round to the nearest whole number when you're doing these. Keep some decimal places. If I don't specifically say in the problem, then try to keep a few so that your answers are accurate. Is that one okay? The next thing we can find, we've got the mean, next one is the median. A median, we use a capital M to represent that, and that's just the middle of the data if it's arranged in ascending order. So if you go small to large, it's just the number in the middle. So let's use our same set of data. If I want the median for this, and I may not say median, I might just say find and then put capital M, so make sure you know the notation I might use. So can I just look at this and find the number in the middle? No, you have to rewrite them small to large. So that would be 5, 18, 23, 23, 26, 36, and 43. So the number in the middle here is 23. Our median is 23. What if I had only had 6 points? Let's say I didn't have that 43 on the end. Then how do you find the number in the middle? If it's an even number of data points, what you actually have to do is take the two middle numbers, which in this case is not very interesting, and then you would find their average, add them up and divide by 2. So if I only gave you 6 points, you take the two middle ones, add them up, divide by 2, get an average. Okay. Any questions on that one? Let's look at this one. So same set of data, but now suppose a new employee is hired who has a 130-minute commute. How does this impact the value of the mean and the median? So now let's recalculate those things. So my mean, my mu. We add them all up. We already knew it added up to 174 before, and I'm adding in the 130. What would I divide by now? 8, because we have 8 employees this time. So we get 304 divided by 8, which is 38. So what happened to my mean? What was it before? Example 1, what was the mean? 24.9. What happened to it? It went up a lot. Okay, so the mean saw a large increase. Okay, let's find the median. So if I list those numbers in order, okay, is there a clear middle number this time? We have 8 points, so we have to take the middle 2. I'm going to add those up, divide by 2. So my median is 24.5. Okay, so the median before was 23, now it's a 24.5. So it changed a little bit, but was it the big increase we saw with the mean? No. Right. So these are both, mean and median are both ways of finding the middle of our data, and they each have their advantages. and disadvantages. What we see right here is a big disadvantage for the mean. If you have one number that's significantly different than the others, then it really changes your mean a lot. You know, I got an average of 38, but there's really only one person who has a commute more than 38 minutes. So it really is kind of off, it's skewed. The median, even if you have some really weird points, some really big or really small, it doesn't change a whole lot. So what that means, we call the median resistant because it's not impacted by extreme values. So resistant means extreme values do not affect its value very much. It's not going to change it a whole lot. That's the advantage of the median over the mean. This next one is a picture, and it talks about how the mean and median are related to the shape of the distribution. So if it were me, what I'd probably do, you don't have to necessarily label the mean and median, I would draw this curve and write this little blurb underneath for each. So there's three possible cases. We talked about the shape of the data in the last one. We know you can be skewed left, skewed right, or bell-shaped. A couple of you on the test mixed up skewed left and skewed right. It's based off the center. So you look at your peak. If it extends out to the right, that's skewed right. If it extends out further to the left, it's skewed left. So there's my center right here. So this extends out further to the left. So that's skewed left. That means you had a lot of really low values. What that will do, if you have a lot of really low values, that's going to drag your mean down. So in the case where it's skewed left, your mean will be smaller than the median. All those little values you have drag the mean down, but they don't really change your median. Does that make sense? Do you want me to let you write for a second before I talk about the other two? Okay. I'll give you a minute and then I'll talk about them. If your data is symmetric, bell-shaped, that means there's really no extreme points either way, so your mean and median are going to be about the same. If it is skewed right, what that means is relative to the center where you have most values, you have a lot of really high points. So those really high points are going to take your mean and make it get a lot larger. So if it's skewed right, your mean is going to be larger than the median. Does that make sense to everybody? Yes, ma'am.
For the symmetric, so they don't have to be like exactly the same.
Right. Symmetric, we're saying about the same. It's not perfect though. So if they're close to one another, it's fairly symmetric. They don't have to be identical. Especially if we're talking about real life data, it's never perfect. So in the ballpark. Other questions? I want to look at a set of data and find the mean and median. But I want to show you how you can do this on your calculator too. If we're looking at really large sets of data, we don't have to take all the time to add everything up. We can use our calculator to help with that. So either get out a graphing calculator or get out your Chromebook. And I want you to go to Stat, Edit. If you have anything in your list, you have to take it out. But remember, don't use Delete. Use your arrow to go up onto the title and just hit Clear. Enter. And then I want you to type in all of these numbers. I think there's 16 of them. Make sure you type them correctly. Is everybody here? Stat, Edit. then we're going to put the data in L1, all of it in L1. So stat. And since you have something here, just go up and clear it. You're welcome. So both columns go in L1. Once you get everything, you go back to stat. And we want to go over to calculate. We want number 1. We only have one variable entered. So number 1, the one variable statistics. As long as you have entered everything in L1 and you haven't messed with anything, you can just enter through this. So just keep it hitting enter. And it brings up a list for us. I may have to take some time to look through, so just give me a minute. Okay, from here, the mean would be which thing? What's the notation for mean? Mu or x bar, right? You see the very first thing on here is my x bar. So my average is 123,193. If we are talking about money, how many decimal places would I go to? Okay, so x bar. Okay, if you didn't get that exactly, what does that mean? It means you typed the number wrong, if you didn't get it. Okay, if you keep going down, so it's telling you, gives you a lot of other information that eventually we will talk about, but we're not there yet. If you just hit your down arrow, you keep getting more stuff, and it has MED. That is your median. So my median here was 127,925. Now, if you only have 4 or 5 points, this probably isn't worth your time. But if I gave you a large set of data or really big numbers, this is significantly faster. You just have to double check your numbers and make sure you didn't type in anything wrong. Let's look at the shape of this to see which one was bigger here, the mean or the median? The median. So, how does that mean my data should be skewed? If the mean is smaller, that means that it should have a skew left. If you look at this on your calculator, remember if we go to second stat plot, you should have plot number 1. I want to turn that on. So yours may be on or off depending on the last thing you did. And I want the bar graph, the second, and then the y equals button. And then go into your plot 1. You have to turn it on. And then you want to select on your type. We want the middle one, the bars. And just to make life easy, if you go to zoom and number 9, that's zoom stat. It goes ahead and takes my calculator to where my data is.
I definitely messed so good.
I got the mean wrong, the median.
I got both wrong.
Okay.
Well, if you type in 1 point wrong, it will change all of them.
I got the median right. The mean wrong. So I don't know.
Hey, I got you too. Okay, so turn it on.
So hit enter, turn it on. that tallest one, you notice you have 3 to the left of that, 2 to the right, so it is a very slight skewed right, which kind of matches up. There wasn't a huge difference between my mean and, left. So it was skewed left, which there was a slight difference between the two, not a significant one. So that kind of matches up. All right, any questions there other than what's the difference between left and right?
Would we have to do what we just did?
No, it's just a quick check.
Okay.
Yeah, I was just showing you to kind of match up with all the other stuff I've been saying. Okay, let's talk about just a couple more things. Mode is the most frequent observation. There could be more than one, so if I had 2 points that each show up 3 times and that's the most, then you would list both of those as a mode. If nothing shows up more than once, then we say there is no mode. So if I went back, just looking at that example 1, the same set of data, what would be my mode here? 23 showed up twice, so it was my most frequent observation. Okay? So mean, median, mode, those are the ways we measure the center of data. All I want to do now is a couple examples and then I'm done. So a set of data includes the values 11, 15, blank, I left out 1, 24, 29, and 31. The median is 20.5. Find the missing value. Oh, come on.
This is an ACT question.
Yeah.
This is when I get it wrong every single time.
Okay. Well, you guys are good at algebra, right? So let's pretend that missing value is x for a minute. Okay. We know if we have to find the median, we have to put them in order, small to large. Is this in order small to large right now? Okay. So there are 6 points. How would I find the middle then? The middle would be right here in between 3 and 4, right? So if there's not just one, you have to take the one on either side and find their average. Add them up and divide by 2. And what should I get for my answer when I do this? What is the median? 20.5. Now, isn't this an equation we can solve? Multiply our 2. So x plus 24 equals 41. Subtract your 24, and we get 17. So there's your missing value, 17. If you had this on the ACT and you got stuck, you at least know how to find the median. So you could always plug in their answer choices and see which one works that way too, if it's multiple choice. Is that one all right? I want to do a problem out of the book. So page 129, number 32. Okay, so this tells us Mr. Zuro finds the mean height of all 14 students in his class to be 68 inches. Okay. Just as Mr. Zuro finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students in the class? So the problem is there were 14 students that he already calculated. And did I give you their actual heights? No. But let's talk about how he would have gotten this mean. He would have added all 14 of those divided by 14 and gotten 68. Okay? Can you figure out how much all of those added up to? Yeah. What would you do? Multiply your 14 over. So 68 times 14. So that means the sum of the first 14 students was 952. We just multiply over that 14. So now to find the new average, he would add up all 15 students. But I know the first 14 of them add up to 952, plus the new student was 65 inches tall, and then I would divide by 15. There's 15 students in the class. And so now we get an average of 67.8 inches. So you don't always have to have the original data to get that. You just have to think backwards of what they would have done. Any questions there? I'm done with the section, so we've got some time to work now. So your assignment is on page 126. There is at least one question, I think it might have been number 19, that has quite a few values. You might want to use your calculator for that one. You don't have to, but you may want to find your mean and your median. Just make sure you type your values in correctly, and then it should be pretty fast.